have gone over this question before, but it's worth mentioning or it's worth asking again. When should oil analysis start for piston versus turbine engines?
Oh, that's a good question. So, in either case, you shouldn't do it right away. So, with the reciprocating engine, you shouldn't do the mineral oil, which is the first oil through the engine. You shouldn't do the first few oil changes. It's just not worth it. I mean, it's kind of fun to watch the values go down, but the first couple of oil changes, you're just not going to get any useful information. So we typically recommend that you start at about 100 hours. That's a good place to start. You'll probably still see worm metals come out in the abnormal worm metals come out due to the break-in cycle, but you'll see them come out, level off, and then be where they should be longer term. So 100 hours to start.
Okay.
Turbine engines, really you have to follow the manufacturer's requirements for that. But the same thing applies. It's a brand new engine. You're probably going to get less useful information than you will after you run it for just a little bit of time.
Another specific question. Do you detect water in glow?
We can detect water in oil. We look at water often with turbine engine oil because in turbine engine oil, they're not changing the oil. They're just sampling the oil to make sure it's still good. With reciprocating engines, it's an interesting conversation because some labs do test water and viscosity with their standard wear metals package. The reason we don't do that is really twofold. One, we are interested in looking for abnormal wear, not other qualities of the water like water or viscosity. Two, when you sample reciprocating engine oil, most often you're throwing that oil away. So the viscosity of the oil that you're going to throw away doesn't really make any difference anymore. The amount of water in the oil you're throwing away doesn't really make any difference anymore. Other labs do other industries. So for example, they'll do an industrial pump, or they'll do a big mining truck or something like that, or a bus, where they're sampling the oil instead of throwing the oil away because the reservoir of oil is so much more, right? So in those cases, it is important to look at water because you're not throwing the oil away. You're keeping it in the engine. You just want to make sure that the quality of the oil is still up to spec. In our case, with aviation oil, particularly reciprocating engines, you're throwing that oil away. So there's really no reason to do the viscosity. There's no reason to look at water. So we really just look for wear metals.
But we have the capability.
We have the capability. Yeah, we get asked that frequently. It's not in our standard kit, but it's something that you can add to the standard kit. The cost is reasonable and it's easy for us to do that. You can see the equipment behind us to do that, but it's just not really necessary unless you're saving the oil and trying to use it for an extended period of time.
Another important question that comes about quite often, not only during seminars, but during conversation with our customers. After an overhauling, when should testing begin?
Yeah, we had a similar question posed about when should you start doing oil analysis with a new engine, right? And it's kind of the same process. The concern there is that you don't want to consider the break-in wear as abnormal wear leading to a component failure. So in both cases, a new engine or a new component in an existing engine, you're going to have the same issue. You're going to have break-in wear. You're going to get higher wear metals at the start. So even after you've changed that component's done an overhaul, you should probably still go through one or two oil changes before you actually start looking at the trends from your wear metals.
So between 100 and 150 hours?
Yeah, it doesn't mean you can't do it sooner. Particularly with an overhaul, you won't get as much of that break-in wear because there's not as many parts that you're breaking in, right? So, but you'll still likely see some elevated wear metals from the new components that are being broken in than you would with an ongoing engine. Maybe I would say maybe 50 to 100 hours in the case of an overhaul, whereas with a new engine, 100, 150 hours might be better.